This lecture is being brought to you in part by the generous gifts of these sponsors.
All right, good evening. Thank you for the introduction, Ken, and thanks for the opportunity to talk about wearables, and thank you everyone for coming. So, Ken already did such a nice job of introducing me. I'm not going to say much other than just give a little context. So, I as you heard, a practicing surgeon. I did a bunch with the Department of Defense and NASA developing technologies, and because of that, I'm very much use-inspired, pragmatic. And if a technology works, great, we'll use it. And if not, we're not going to use it in the operating room. We're not going to use it in the aircraft. We're not going to use it undersea. We're just going to get rid of it. So one important thing I will say, a lot of people come and talk and they sell you what they own. I do not own anything. I don't have any stock in any of these companies. I'm not getting any money from any of these companies. And finally, I'll say that this is just my opinion. It does not represent the Department of Defense or any federal agency. So with that, we'll get started. So I worked at DARPA, as Ken said, and at DARPA, an old director had these criteria that they would use to develop new disruptive technologies. His name was Hallmeyer, and the Hallmeyer questions or criteria. And he'd say, you need to say, to figure out something that's going to change the world, what is currently done, what are the limitations, and then how can we change it? And how much money is it going to cost, and some other things like that. So we're going to start with where wearables are right now. And I'll ask questions. Feel free to not participate if you don't want to, if you're uncomfortable. Who is wearing a wearable device or has a wearable device? Anyone have a fitness tracker, smartwatch? So it is amazing to me. I think that is correct. If you look, it's about 1 in 5 U.S. adults has a wearable device. From my time with the big device companies and at DARPA and NASA developing wearables decades ago, I would say the big device companies have had amazing heart monitoring technology for decades. It is very high quality data, so you can make good medical decisions, but it is extraordinarily expensive, in part because the FDA regulations required them to put so much money into it. And the good news for that is that technology is now transitioning from a medical devices into these wearable consumer technologies. And the couple areas that we're going to talk about today, heart rate monitors, activity monitors, fitness trackers, and glucose monitors, surprisingly. We've been dabbling in glucose monitors, really quite interesting. And if you take nothing else from the talk tonight, this is what you should take from it. The wearable devices in general, if you look at them now, are not great at giving you an absolute value. In general, the wearable devices give you a change in your health status. So your temperature is up or you're down. It's down. Your heart rate is up or it's down. They provide pretty good motivation. My wife loves her Apple Watch in 10,000 steps a day, which is valuable. And they build good habits. And I'd say that the main areas that they work in are the big 3 that are critical to health: exercise, nutrition, and sleep. So that's sort of the state of the art. But what I get medical articles and journals and lay press deluge every day. And what I hear every day is, oh my God, if you hit 10,000 steps, we're going to add 4 years onto your life. If you are in the lowest percentage of people that exercise and you go up to the highest, we'll add 10 years onto your life. And you're saying, really, is this accurate? And so they don't really deliver on many of these promises. They want you to buy the device. The company wants you to buy the devices. And the reasons why they don't deliver is there's a couple. One, and we'll talk about these obviously during the talk. The data quality is relatively poor. So if I take my Apple Watch and put it on this podium here, take it off, it'll still give me my heart rate for 15 seconds, or 10 or 15 seconds or so, which is obviously, it's not on me anymore. It shouldn't be giving me my heart rate, but the algorithm keeps ticking along. And if you, some of you maybe like use a Peloton or other exercise bike and you wear one of these, you'll see when you're exercising that your heart rate lags by maybe 10 or 15 seconds, depending on which device you're wearing. So the bad news is it's worse when you're active. It gets worse when you're sick. I'll show you some of my personal data. It gets worse when you're sick, just when you need it, and it gets worse if you're in extreme environments like flying a tactical aircraft or diving in a SEAL team. So the scary part of the technology is the security and privacy issues. You guys probably have experienced Alexa or your phone. You're sitting there, so be talking with my wife. We'll be having a conversation. I have Siri turned off on my phone, which, by the way, IHMC did help develop Siri back in the day. So I have Siri turned off. She has it on in her phone, and then about maybe 10 minutes later, we'll get this ad that is obviously heard our conversation and sending us a focused ad. So that's a little spooky. And the saying in the industry is, if you are not paying for the product, then you are the product. So we'll talk a little bit more about that, but that is an even bigger problem potentially for the military, where you are potentially able to track where your warfighters are, and our adversaries can determine where our warfighters are and what they're doing if you're not careful. And then I will say, you look at the processor cores, it's amazing what the AI and the advanced chips can do now, but they burn through power. I don't know if you guys remember 3 Mile Island. Do you remember 3 Mile Island? Do you know they're restarting 3 Mile Island? And do you know why they're doing it? They need the power for the AI, for OpenAI, to train the algorithms. So they're turning the reactors back on, some of the reactors. So that's how much power you're talking about. And so what I'm going to talk about, there's a Morley Stone, who's the current director here, and I are PIs on a project that's called Apex, and we're pushing beyond some of the limitations I just talked about, and we're going to talk about some advanced wearable devices, novel electronic skin that we developed, some new materials, and non-invasive nerve stimulators, and some human-centered artificial intelligence. So, and the reason why I sort of got into this, I was practicing as a surgeon, but I also did some work with the Astronaut Corps and some other organizations, and it seemed to me like for example, this is a B-2 Spirit. This is an aviation town, so that's an amazing platform, stealth bomber. I picked this as an example because in this platform, you take off from the United States, you fly around the world getting refueled in the air like that, you drop your payload, and then you come back. It's a day and a half, a small crew that's flying for 36 hours. So imagine how hard it is to stay alert. And one of the biggest issues with regards to error and mishaps is fatigue. So we looked at this and we said, this is a great opportunity. We have some technologies we could potentially develop to help with this. They have sort of left the pilot out of this. They had this very complex aircraft, but they sort of ignored the pilot. And these wearable monitors can help us figure out what's going on with the pilot. So, so we have some partners I'm going to talk about and what they're bringing, but the wearables, state-of-the-art wearables from a company called Polar, the latest and greatest chips from Texas Instrument, very low cost sensing and processing chips, secure networking and analytical platform by a company called Vigilife. Our partners from Georgia Tech are developing this electronic skin, which is super cool. We'll talk about Medtronic. We're very briefly going to talk about some implantables, which I don't know if you guys have been following those. Some of you may have Medtronic insulin glucose monitors and insulin pumps, but they have pacemakers that are so small that they're being implanted in the heart now. No longer have this big package anymore. So it's It's truly amazing. So we'll briefly touch on that. I mentioned the Abbott Lingo glucose monitors, and we have some friends from Ohio State University and the Air Force Research Lab that are comparing all these wearables and telling us which one's good, which one's bad. Oh, they're all bad. Sometimes. And then finally, it's not as spooky as it sounds, but some non-invasive vagal nerve stimulation that you put on your neck, you press a button, and it stimulates the nerve and relieves your stress, improves your mood, and maybe even makes you learn a little bit better. So, for those that are medical providers in the audience, you can take a nap. You can rest and digest. So, when you see a threat in the world, this is a high level. When you see a threat, your autonomic nervous system is what tells your body what to do. It basically says, hey, it activates this sympathetic nervous system, and it says, increase your heart rate. You need more blood. Your liver, release some glucose so you have some energy. Your body is telling you you're either going to fight or you're running away. So that is the stress response, fight or flight. And then they have a separate part of that, which is the parasympathetic nervous system, that is the rest and digest. So the threat leaves, and then your body says, hey, calm down, everything's good. Let's digest your food. Let's get relaxed. So in general, people think stress is bad. Stress is not bad. Stress is necessary, especially as we get older. If you don't use it, you're going to lose it. So stress is only bad when it is too much acutely, but more commonly for most people, it is that we don't have the stress go away. We have chronic stress, and you don't get to the rest and digest parasympathetic nervous system. You can't recover, and your body starts to wear down. And so we're going to talk about some techniques that we have used to help with that parasympathetic nervous system activation, and that sort of brings up this vagus nerve. The vagus nerve is one of the main nerves. It goes from the brain down to the body and from the body back up to the brain, and it's got both sympathetic and parasympathetic components to it. And we're going to talk more about the vagus nerve later on in the talk with that vagal nerve stimulation. But I want to, anybody know what heart rate variability, have you heard that? For those that are with their devices, so you hear everyone says HRV. What's your HRV? So HRV isn't really complex. And here you can see low heart rate variability is basically, if you see here, the amount that your heart rate varies from beat to beat. So if you are sympathetically activated, your your heart rate variability, the heart rate gets faster, and the period is more constant. So you're fight or flight. And if you are rested, what happens is you see these variations, 0.9 second, 1.2 second. You are in the relaxed state. So that when many of these devices are measuring your heart rate variability to figure out whether or not you're stressed or whether or not you're relaxed. Some of them, like an Oura Ring, you'll see this in your sleep score. In other wearable devices, you see it in your stress or readiness score. So how do we measure? Your heart rate variability, among other things? This is Polar, latest and greatest Polar devices. So they're part of this APEX Assessing and Augmenting Performance in Extreme Environments program that I mentioned. That's a Grit X2 Pro, which are the latest. They're super rugged. They're beautiful watches. And you can measure your electrical heart rate if you put your finger on it. You can measure your heart rate and your heart rate variability just by wearing it because it shines a light in and measures your blood flow. You can measure your oxygen saturation and your skin temperature, and it does a whole bunch of other things. GPS, maps, route guidance. It's amazing. So what we also have been using with some great success is this 360 device, and you might wonder, why do you want all the functionality of this watch in something that's just a black little tiny sliver of plastic with some electronics and no face, because some training situations for the military, or where you're out in the dark night, or you got your selection process where you don't want them to know the time, you don't want them to know where you are, this 360 device has been super helpful. So we have used that. And the one thing I will say that is also very important, most of the companies don't want you to see their data, because the data is not super great, like we're talking about with the algorithms. The Polar software development kit allows us to control the data that we're collecting, what data, how often we're sampling, how to access it, and then how to integrate it with other devices. So for example, the Sennheiser Sport earbuds, excuse me. If you guys have seen those, you can listen to music, but it also has an optical heart rate variability, and temperature sensor as part of it in the ear. So very nice. And once again, I was very surprised by this. I prescribed continuous glucose monitors as a physician for a long period of time. I had no idea what we were going to find when we started looking at continuous glucose monitors in healthy people. It was, and we'll go through some of that. It's quite valuable. This is just an example of the wearables data. So we do some integrated testing device and some training events for the military, one of which is called Bold Quest. And in Bold Quest, this last year, actually a couple years ago, we put this Polar chest strap on. So you got a strap, it sits right over your heart, does an electrical tracing of the heart, electrocardiogram. That version is used in multiple people, so you can monitor the whole team. And then we had them wear those watches that optically measures the heart rate. And if we just pick one subject for this is pretty typical. You look, the error rate is 10 to 20% from what the heart rate is on the chest monitor electrically versus what it is on the wrist. And that's like 11 beats per minute in a typical person, which is a lot. 10% error second to second. And as I mentioned, this is from OSU and AFRL, where they have compared a whole bunch of different devices. So this isn't just the Polar devices. This is pretty much all the devices that are similar devices, similar watches. You're getting the same results. And it gets worse the more active you become, which is if you're trying to make a decision about like whether or not someone's been shot in the battlefield, and as a trauma surgeon, whether or not you can provide them medical care, the data is really not good enough for us to make the critical decisions quite yet. So, and this is just to show you what happens when you get sick. So I back, my goodness, 3-4 plus years ago, beginning of COVID, I went through the Atlanta airport, military essential travel, and just is amazing. Sad but amazing, I guess. But I saw three passengers in the entire airport because at the beginning, it was the beginning of COVID. Well, unfortunately, I also got COVID during this military, this essential travel. And they now have it on the Oura Ring. You'll see it on the Oura Ring. You get minor or major signs. But at the time, they didn't have it. It monitors your temperature, your activity, and your heart rate variability, your respirations, by this ring on your finger. And so what I saw was, this is my Ultra watch here, if you look. This is called normal sinus rhythm. This is what a normal heart tracing looks like. And then here is what you start having is what's called ectopy, a certain kind of rhythm. It's not a super dangerous one unless it happens really frequently. But I only did this after I noticed something else, and that was, here's my sleep score. I was rocking it. I was like just so excited. Sleep score is in the 90s. I'm like, I am good habits. I'm doing all I need to do. And then I noticed, oh, wait a second. Why is all of a sudden my data not there? And then all of a sudden it's blank. I'm like, did the company update the algorithm I don't know about? But what happened was I started to have enough irregular heart rate and rhythm that the algorithm no longer recognized my heart rate and my heart rate variability. So my sleep scores went to 0. And so like a couple days after that, I got a fever. I started to have a runny nose. I'm like, oh, I have COVID probably, and tested, and I had COVID. So they now have changed that into a plus, and that you can detect that you're getting sick, but unfortunately, you can't really use it anymore if you have an irregular heart rate. For those that have irregular heart rates, it's not of great value anymore. So this is BoldQuest again. We wanted to figure out what happens in extreme environments. So we got a medic, and we put this Polar Team Pro and a GridX Pro on a medic, and then we flew them on a bunch of Huey flights transporting simulated patients. And yeah, it holds true once again. A higher quality chest from ECG signal from the electrical. The strap is not super comfortable to wear, but it's pretty good quality, better quality. And the wrist one was a lot lower quality because the vibration of the helicopter. So, and the other thing that we saw, which was encouraging, if you look, this in here shows that the sympathetic nervous system was, when he was getting stressed about flying and having to take care of a patient, his sympathetic nervous system started to dominate. So you can start measuring the stress level even when they're flying on a helicopter. Maybe not as precisely as we'd like. So I won't go too much into this other than to say that the TI Silicon, Texas Instrument, is they make billions and billions of chips. American company, make good chips. They have some of the latest and greatest CPUs that are wearable. This CPU, this 600 mega floating operations per second. Back in the day when I was an undergrad, that was like a supercomputer, and if you look at what that is now, the Blackwell chip from NVIDIA is over 1 million times more powerful than that. But it takes incredible amount, as we're talking about, incredible amounts of money, incredible amounts of heat it gives off. But that particular chip is like $3 for Texas Instrument, as opposed to the $2,000 for one of the single NVIDIA chips. And the other thing that they have is some very nice analog to digital converters. Basically, you can take the signal at the point of where you want it and convert it directly into ones and zeros. And you can markedly decrease the noise by doing that, not having to transfer it. And you can get like very sensitive and very frequent measurements of the signal, of the electrocardiogram. And for IPG, this impedance plethysmography is basically you put a little bit of electrical current through the tissue. It'll tell you what your blood flow is. It'll tell you what your tissue edema is, so you can get a lot of information from that as well. We are going to, it's probably at this point probably one of the best in the world, at least we're aware of. And this is not super sexy device. It's not like they've spent $100 million. They spent $10 million on the bezel alone for this Ultra. This is something that is rough and very flexible platform that we can play around with and figure out what we need. So, what DARPA asked us to do with some of this technology, we had something that was for physiologic monitoring. They were concerned that electromagnetic fields were causing problems for the warfighter. In particular, for a pilot who had a mishap, they thought maybe he got some very strong electromagnetic fields that caused him to have a problem. There used to be this concern about, still some people have concern about having cancer from having cell phones, which is probably not something, but if you look at some of the radars that the military guys fly through, it's a different story. And there are some of these anomalous health incidents that we've unfortunately heard about, where some people in the embassies maybe have been exposed to some electromagnetic fields as well. So DARPA said, hey, can you design us something that's small and cheap that we could put on a pilot and let a pilot fly an F-16, and we can record them? We said, sure, we'll do that. And so we did it. This is the electromagnetic fields that a pilot in an F-16, you'll see that's the flight path, and the color basically tells you what the electromagnetic field is they're being exposed to. So it was a very cool project. It's still, for various reasons, sensing electromagnetic fields is of interest to us and to the military. the other thing, you can do physiologic monitoring. We already talked about that. You can also potentially sense the ionizing radiation in some of the gases, the organic, volatile organic compounds. But if you look at this, you'd say, oh man, that's really cool. But once again, wouldn't our adversaries love to know what the electromagnetic fields were in our latest generation fighter aircraft? Wouldn't they love to know what the flight paths are for our... So there is a problem with the control of the data and the privacy. It's privacy from a personal standpoint, security and operational security from a military standpoint. This is another test that we did that demonstrates this. Once again, it's at this Bold Quest event, and it's wearing this Polar Team Pro. These are the people that are instrumented. You can see exactly what they're doing throughout the entire day. That if you had this kind of information and it was an active duty experience data, you would potentially be able to track exactly where the warfighter is in the forward operating base and exactly where targets of interest are. So this is not something that we want to let others have access to. In addition to our own personal data, you don't want them to have access to the relevant military data. So this is the company I mentioned called Vigilife. Their product is called Safeguard. And basically, it's a secure data collection, processing, storage platform. And I won't go into the details of it. It's cloud. You can do it locally into the cloud, and it's certified increasingly for federal use, including the military. But the interesting part's at the bottom. The person that is wearing it can say, okay, I only want myself to be able to see the data. I will let my my boss see my data. This is collected for some people that were constructing a building in Alabama in the summertime, and they were getting heat exhaustion. So they basically said, I don't want you to be able to say it was me having a problem, but I'm letting you see that the whole group of us together. And then finally, if they're all right with it, you can say, yeah, you can have my data. Go ahead and look at it. So, and it's done securely with privacy in mind. And just to show that this is of some value, I'm just going to show a few papers, a little data. This is a paper that we published in Frontiers in Physiology. We had operators wearing a Garmin watch and an Oura ring, and they were going through one of the most intense selection events for the military, or a week without sleep where they're just getting punished. And we wanted to try to figure out if we could help them do better and also help those that are determining whether or not they're a good fit for their organization, whether or not they were a good fit for the organization. And it was very interesting. If you look at this, once again, heart rate variability comes up. You look at heart rate variability, the elite operators that made it through the class in general, at rest at the beginning, they were more rest and digest. Parasympathetic nervous system was higher. And then when they started having go time, they know that it's coming, the sympathetic nervous system ramped up, and then when they're in the midst of it, they went high. And then when they were done, they went back down, recovered quickly. And there was a difference between those that made it through the event successfully and those that did not, which may seem simple, but it was revelatory, I think, to some that you could do that with a wearable. So we're talking about the challenges that we have with the signal quality. So I lived underwater for a couple months of my life, and at that time it was both military and NASA related mission. Whenever we were out in the water, they had no data on us because essentially the monitoring systems were ineffective. I'll leave it at that. So what we said, it'd be nice to have something that could use underwater, that we could use in Pensacola in the summertime when you're sweating. And so we have developed, and this is from Georgia Tech, this safe, non-toxic nano membrane, essentially, that's an inorganic compound that is basically fits right on top of the skin. It conforms to the skin. You'll see it right there. That is this membrane, this myxine, and there's normal skin. And very conformal. It conducts electricity very well, and it's because it's so conformal, it sticks to the skin when you move the skin around, when you flex your wrist or move. And it even though it looks dark, it does let the infrared light go through, so you can also do optical monitoring. And you say, well, what good is that? And what good it is it lets you improve the signal to noise and the signal quality by at least 3 times and up to 10 times. So for those who are in the medical profession, or patients, the infamous red dot that you stick on the chest to get your ECG, we put that on someone's wrist, and we did also these ultra-thin electrodes, E-skin, and then we had them do this, flex back and forth, and we recorded the ECG, and you'll see this is a nice-looking ECG. It continues to be nice-looking ECG, despite the fact they're moving a wrist. And if you look at what happens with the red dot, you see all this noise in there. So it looks quite promising for us to be able to use. And then I'll say the other thing is it's super easy to put on and to take off. So you can put it on just by putting rolling it on with some PTFE or Teflon, and water won't take it off. You put a little soap on it, rub it, comes right off. So this is one thing I have to say that there may be some commercial application for at some point in the future. So I talked about implantables. Please do not get spooked or scared. So as a surgeon, I put in a lot of different implantables for medical disease treatment. This particular, it's about the size of a AAA battery. It's called the Link 2. It's from Medtronic. And for those that have had syncope or have passed out before, you know what happens. The doctor doesn't know, did you potentially, until you look, did I have a seizure? Did I have a heart arrhythmia? Did I have low blood sugar? What is the problem? So they put a monitor on you that maybe can figure it out. They do some EEG studies, maybe figure it out. For those that they can't figure it out, they use these loop recorders to see whether or not it is a heart rhythm problem. And what basically, if you make a very small incision, maybe 5 millimeters or smaller, and you just slide this in the fat here, in less than 30 seconds, put a steri strip on it, the procedure's done. And it stays there. It's amazing. They're down to counting the number of electrons that these things use at one time. It is good for 7 years, that little device. And it monitors your temperature, your heart rate, and your movement. And what we're going to do is take some people, old people, obviously older people, have a bigger problem with syncope in general than younger people, but there are some younger people that have had the linked devices put in, and then they have figured out what their problem is, and they still have the linked device in, and so they're healthy. And the reason why I say younger is because we're interested in potentially testing the age of people of the age of warfighters, people in the military. So they still have these devices in, we're going to put a whole bunch of other wearables on them, and we're going to see whether or not the data from these implanted is better than the one on the wrist or better than the one on the finger or the chest. I think that they're going to be better, but that's to be determined. So anyone here have a glucose monitor? I've worn them. You'll see my arm here in a minute. I'm not a diabetic, but there's now have transitioned these devices from diabetes care into health. So and if you want to get one of these devices, it's about $48, and you're good for 2 weeks. And you say, why would I want to do that? Well, I'll show you why. It is interesting. So they go basically, this is one that's an expanded view. They have this little sensor that goes in, and it doesn't hurt. It goes into the interstitial fluid, and it monitors the glucose that's in the interstitial fluid, as opposed to what normally happens is you prick your finger or you get a needle inserted into your vein, and then you draw the blood, and then you check the glucose with that. So that happens once in a while, I guess depending on how much you can tolerate pricking your finger or getting blood drawn, not too frequently. This is constant and lasts for 2 weeks. I won't go into the details on this side, on some other ones, but it is surprising to me. So it's a very sensitive indicator of stress. So you could get up, be stressed about giving a talk, your glucose will go up. You could be stressed about a test, and your glucose will go up. You can go out in heat, and your glucose will go up, or be getting sick. It's very sensitive, but it's non-specific. So you don't know why you're stressed, but you're stressed. For the women in the audience, or the providers in the audience, they're probably, unfortunately, those that have been pregnant are familiar with the oral glucose challenge or glucose tolerance test. So basically, if you're concerned someone's got a problem with their sugar going too high, you give them this super sweet drink, and then you follow their glucose. Nasty. It's one of those nasty things. So we wanted to figure out how good these devices were, because they're probably, we figure it's about 10% error, but we wanted to check. And so the Special Forces guy said, I'm going to do my version of the glucose tolerance test, and got a monster and chugged a monster as fast as he could. And then we checked with the finger stick, the capillary blood, and then we checked with one of these glucose monitors. You'd hope that those would be the same. The red one is the glucose monitor, and this blue one is the finger stick, and you see there's a pretty big difference, unfortunately. And 15% is what it was calculated out to be. Once again, this is all those devices. We wanted to see, is it different if you're wearing two devices at the same? It should be close to the same, you'd hope. No. About 10% difference looking at them. Which does make you wonder how you're treating someone who's got diabetes well enough. But I will say, and this is the Stelo, which is from Dexcom. A lot of people also, Abbott makes one, Dexcom makes one, and Medtronic makes one. And you'll see it's a similar kind of thing. It's two different ones, and we're just looking at the peaks and the troughs, and you'll see there's a very wide difference between the two of them. So how could we use it? So that was the question we asked ourselves. We're one of the few, and I think we're the first, this will be the first paper actually that has the use of both the continuous glucose and a continuous ketone monitor. So you can measure other things now. And I'm sure, because we're in Pensacola and you guys are at the evening lecture, that there are some people that are on the ketogenic diet here, correct? Ken Ford is a world expert champion in the ketogenic diet. The ketogenic diet has health benefits. The challenge with the ketogenic diet for the military population is that they can't stay in ketosis. They're eating meals ready to eat, which are loaded with carbs, or they're having pizza or beer, and those things are going to knock you out of ketosis. So what we wanted to do in a study that SOCOM asked us to do, we've proposed to look at using a ketone ester or a ketone supplement to help the guys, men and women that are hitting their head when they're learning how to jump out of airplanes. There's about 17,000 people a year that go through jump training, and you'll see this is a picture from this study that we did. You'll see all the gravel flying up. This is just in the second week where you're jumping off doing a simulated jump off a little platform. It's about 6 feet. And in that, about 20% in one day, 20% of the people who are going through the class were hitting their head. So, and multiply that times 17,000, that is not a small number a year. So what we needed to figure out is, so we know that they're exercising, which can change your ketone levels. They're having, diets that are not ketogenic. What is the dose that we need to give of a ketone ester supplement that with the military activities will end up having them in what's called therapeutic ketosis, or above a level? We shot for above a level 2. The red is this study that we did here at IHMC, 16 people, 132 days of taking this ketone ester supplement while wearing the continuous ketone monitor and glucose monitor. You'll notice that when we came up with the right dose, it was a therapeutic level that lasted for their whole training. And the other thing which I will show, and Ken can attest to this, you talk about it with, for those that want to know more about the ketogenic diet, your glucose also goes down. That's the glucose tracing in the blue. And then you look after the ketones wear off and they're sort of done, still going through some stressful part of the day, their glucose goes up. But I will say, we just completed this study and outbriefed it, and it looks like ketones might be a benefit in TBI. So we have to do some more studies on that, but it was preliminarily positive results, and they're talking about a larger follow-on study. So, and of course, our friends wanted to see, there's a whole bunch of recovery tech. Dave LeMay is in the audience, so I'll say, Dave, I don't know which recovery techniques work well and which ones don't work so well. I know you're an expert. What I do know is people try a whole bunch of different ones and they combine them. One of the guys that is a friend of both of ours decided, hey, you know what, a good way, if we're measuring stress, and we can use heart rate variability, we could also use glucose. But the problem is, I don't know whether or not this glucose monitor is going to work in a sauna. I don't know if it's going to work in a cryotherapy chamber. So he wore the glucose monitor 215-degree sauna, and it still worked. It stopped, but when he got out, then the data was downloaded. And when he was minus 180 degrees, it stopped working in the cryo and then when he came out, when he warmed up, it started working again. So they are potentially going to be of help figuring out some of the recovery techniques that could be of value. And we tested this in one of these integrated training environments called BullQuest, the same one that we were talking about earlier. And this particular person was wearing an Abbott continuous glucose monitor, and they put on what's called MOP gear. MOP gear is the stuff that you put on to protect yourself from chemical or biological threats. It's very heavy, and it gets very hot. So this is in the summertime out in Southern California at Camp Pendleton, and you can see as soon as you put the MOP gear on, starts getting hotter, gets stressed, the glucose goes up. You end the exercise, the glucose goes down. Of course, if you eat, your glucose is going to go up as well. So he went and had chow, glucose went up, and then you look, and once again, he starts the exercise again, glucose is, depending on what he's doing, is going up. So you can get a pretty good sense of how stressed the Marine was when he was doing these. So once again, sensitive but non-specific indicator of stress. Let's see how much time. So I'll zip through these a little bit more. So this is a very interesting technology, vagal nerve stimulation. So we talked about the vagus nerve up to the brain, down to the body, helps with inflammation. It tamps down inflammation in the body. It helps with mood, mitigates fatigue, and potentially, as I said, helps with learning. And how did they figure this out? Because the vagal nerve stimulation device was approved by the FDA for things like seizures, cluster headaches. And patients it doesn't hurt, you put it on your neck a couple minutes, and then you take it off, you stimulate it for a couple minutes more. They said, oh, hey, I'm not having the cluster headaches anymore. I'm feeling a little bit more energized. My mood's a little bit better, and I don't know, maybe this is crazy, but maybe I'm learning things quicker. So we actually did some tests with funding from DARPA with this gamma-core device, looking at intelligence, surveillance, and reconnaissance, the ability to look at images, learn how to look at images and detect changes in them and targets in them. This one we reported was learning a second language. So we went out to the Defense Language Institute, and we had one of these devices that looks just like it, sounds like it, doesn't stimulate, and we had the other one that does. And we didn't know which one it was, the student didn't know which one it was, and the ones that were getting vagal nerve stimulation actually learned Farsi quicker than those that were not. And such that the people that were taking the class that weren't in our study were calling us up and saying, hey, can we get one of these? And then we looked, there's another from our AFRL colleagues that they looked at the same thing for NASA, and they found that it also helped with sleep deprivation and helped with mood and, mitigate fatigue. So much so that we are developing these for the Air Force in this APEX program, and a patch that you can put on so you can maybe wear it while you're potentially flying or a patient in the back of an aircraft. But they're being deployed across all the services: Army elite units, Navy elite units, Air Force. So it's an exciting time. And I'm putting this in there. Once again, I don't own any stock. I'm not getting paid by Truvaga. But everyone at the end of the talk says, where can I get a vagal nerve stimulator to try out? So this is Truvaga. It's the same basic device. It's a commercial off-the-shelf device focused on wellness, not focused on any medical diseases. And it's about $500. We have some people here that use it, that like it. And I will say, if you really have interest in this topic, we just had a fascinating STEM talk we just completed with J.P. Errico. J.P. Errico is the guy who invented these, and it's going to be released in the next couple weeks. So listen to that. He had what prompted him to do this. His daughter had some health problems, and that's what prompted him to do it. And I can say also that JP is going to be joining IHMC as an IHMC researcher in the upcoming weeks as well. So we're super excited. And where's Carol Carlin? So there's Carol. So I will say all this that we're doing, we do a lot of stuff in the field, but you guys have seen this. It is a beautiful brand new building. And enables us to do so much more. Everything from the molecule, looking at genetics and epigenetics, all the way up to the latest and greatest gym and training, where we have an aging study that's going on now. We have some of this in Parkinson's as well. So I mention this and I mentioned Carol, because we have these events called Better Together. I don't know, there's some I've seen at Better Together. It's a morning. You come and you get to see the robots dancing around in the robot lab. You get to go over and tour the new building and get to hear about some of the great work that's being done here. I highly recommend it. You can reach out to me, and I'll just send you over to Carol, or you can reach out directly to Carol. But it's fun. So if you have interest and have just a morning, it's flexible dates. We get enough people and we put on a Better Together. I think you'd really enjoy it. And once again, the building from the outside is beautiful. Wait till you get on the inside and see some of the tech. It's amazing. And part of this project, we're also, APEX, we're also doing multiple modeling approaches to figure out how these technologies, how we can sense the fatigue of a warfighter, how we can mitigate it. And there's some unique things that we do here. This ACTAR, which is computational modeling of the way humans think on a computer, that is interesting. I will say probably most people go directly down to there. Ken and I were talking before this. Everybody talks about. I can tell you every day from my medical journals, half of the articles talk about large language models and foundational models, and ChatGPT being one of the familiar ones. But it is. I think it's a brave new world. I think it's overhyped. I'll let Ken, as the computer scientist and the AI fellow, can talk about this, but I do think we had a challenge analyzing some of our wearable data, particularly some of the continuous data, and I think there's an opportunity. There's been some very interesting papers. But the most important part, we need the software. Once again, we're back to the SDK. If you can't give the person that's wearing the device some kind of actionable information, they won't wear it anymore. We find this especially true in the elite guys that are busy doing God's work and the tip of the spear for us. If you can't give them something that's going to help them do their job better, they're not going to be wearing or using the tech. And so I think the Polar SDK allows us to integrate devices like we talked about, but most importantly allows them to get some actual data around the time that they're training. They have some interesting things that we're helping develop in this project. Stress management, but the other one is the teaming. They have a coaching system in development, and that is something I'm super excited about, because you think about what we do for one person and how hard it is, but imagine if you're trying to team together on a squad or an air crew. If you can track their vital signs, I don't know that we're going to go all the way to their brain tracings, but their heart rate variability, potentially their voice is another thing that's critical. And then you start looking at what outcomes they are having. You can start figuring out if something's helping them or not. And honestly, a good example of that, human-machine teaming, you have these small UAVs. You look at like Ukraine right now. There are millions of small UAVs are being used a year there. But unfortunately what happens is that the person that's using it is head down looking at the UAV, and it's not clear whether or not in some situations that's actually helping or hurting, because that guy's out of the fight and you got to have a couple other people there protecting that person, and so you're taking people out of the fight. But with some of these technologies, you really can help figure out whether or not these technologies are helping them or not, and how the team is functioning. And this will be my final one. Anybody, a techie in the audience that likes the CES? Anybody know what CES? Yeah, so Computer Electronics Show is the big tech event in Las Vegas. It happened in January. And honestly, amazing, humongous TVs, some other things. They have all those kind of things that you love. I love. But one thing that was really spooky to me is this OMI technology. They have some of these technologies. OMI, so I'll just start with this because it was super spooky to me. It's not as bad if you watch the video. This version of it has got microphones that record your conversations, transcribe it, and then sort of buzz you or ping you with AI 24/7. So it's like having an Alexa on your body or your phone and Siri on your body. But this one goes even further, and in the next quarter, we'll have an EEG tracing as part of it as well. But if you look at what this says, a French girl likes you. Tell her, I'm like, that is really spooky. Maybe the application of, someone say, hey, you have blood work today, don't forget, or, oh, hey, you closed a contract, that's good. But, it's a brave new world, and how valuable is your privacy? How valuable is your data? Do you want to let somebody have it so they'll build you your own personal chat GPT? No, I'm not ready for that. But that is just one of the, that's where we're going. This was put out, and you have to pay for this to wear a microphone 24/7, and they're scraping all your data. So it's crazy to me. And with that, I'll put up where we started, and we're done, and we can use this as sort of a reminder and answer any questions.
Doctor, your vagus nerve stimulation research, doesn't it support the power of relaxation or peace? Have you ever had a meditation expert do the same test to try to compare it to the vagus nerve stimulator?
Yes, so that's a great question, and I would say the way that we looked at this at the beginning, it does improve relaxation. It stimulates the parasympathetic nervous system, but the DARPA program that this was based on was called Targeted Neuroplasticity Training, or TNT, and it was basically to try to help the brain and the nervous system be more plastic or receptive. And so from what we found, it's honestly, it's best when you combine it with something. So combine it with relaxation. So I think that they're potentially additive. Some people, I'll be honest, if you look, I'd say, it's unclear exactly how much, maybe 20% of people don't see a great effect with it. But what we have seen, for example, in PTSD would be a good example. If you combine that with cognitive behavioral therapy and the vagal nerve stimulation, they do a little better. Yeah. There's a microphone right up, coming on the other side.
I have a suggestion.
Yeah.
I think it'd be interesting to test firefighters.
Yeah.
Our son is a firefighter, and his schedule and his sleep is insane. And I'm just wondering if there would be a way to help them monitor.
I would say thank you for his service and your family's sacrifice. We have some firefighters in our family as well. And so I think that's a great idea. We have done some first responder. I will say, I was talking with Dave beforehand. As a surgeon, I got something in the mail in the email this morning. It's the same problem as a trauma surgeon. So you have terrible hours, and in fact, if you look, it was over 2/3 of surgeons do not even meet the basic exercise or sleep requirement. So it's the same and what happens is you end up getting burned out, you wear down your body, depressed, and potentially have other problems. So I think it would be a great, we have had some discussion with the firefighting community closer down to the Ocala office, I guess, but yes. Yeah, that's a great idea.
Time for one more question.
Yes.
What is your opinion and what do you see for the future of the implanted Inspire device that controls breathing during sleep apnea?
So I will have to figure out how to phrase this. So, without divulging any personal medical data, I have a family member who had one of those put in, and she has yet to have it turned on. It's not in my immediate family, it's my extended family, but I'm hopeful it's going to help her, but I have not had any experience with it yet. But there's some amazing new, because the link that I was talking about, it is going to potentially, if you use the latest and greatest electronics, they're so small now, it will be 100 times smaller. The next version will be about 100 times smaller. So you can start getting really small and really capable devices. So.
Let's thank our speaker.
Yeah.